Hi everyone and welcome back to the lab. Today we are looking at yet another old but good piece of technology, and today we are looking at a magnetic stirrer and hot plate. So this is laboratory technology, and that's why I like to review such kind of technology, because it's meant to be precise, solid and durable. So that's why I like to review lab tech. This particular device here was made by the German company Ikamag in 1985, so it's pretty old. It belonged to a laboratory in my city, and it was then donated to my father, who used it a few years. Then it was broken a few years, and I just picked it up and repaired it, and now it works fine. As you can see, it has seen better days. I mean, the paint is coming off everywhere, but yeah, still works. And when I'm sure that everything works fine on it, I will just redo the paint, and then it will be like new. So, as you can see, it consists of two parts. You have a stirring part and you have a heating part, because this is also a hot plate. How you are supposed to use it is just put a flask on it with a stir bar, and there's a magnet under the hot plate that is spinning, and the stir bar is magnetic as well, so it will start spinning on top. And this allows to stir media or to stir chemicals without touching them. And that's the advantage of a Magnetstirrer. So on the right side here, you can control the motor that is under the hot plate, and you can control the speed here that goes from 100 to 1100 RPM, and you can just turn it on with this switch. On the left side you have the heating part, so the hot plate, and you can turn it on with the left switch, and you can set the temperature with the knob on the left side that goes up to 300 degrees Celsius. If I turn it 90 degrees, then we can see here the original sticker that says that the tube is red, because this is a series actually. Ika is the company, Ikamag is the Magnetstirrer series that still exists today. They are still making Magnetstirrers, and red is the model. Here it says also 200 to 250 volts, 50 to 60 hertz, so that's European, and there's the power as well, 620 watts, and it goes from 0 to 1100 RPM. Here you have the address and the name of the company that is written out. So Jankent Kunkel GmbH, IK-Werk, and it's based in Staufen, Germany. Then on the back side we have the power plug. That is pretty weird, I must say, because it's like an ordinary power plug, but it has a notch on the top. I don't know why, but yeah, it's not the normal size and shape of a power plug. Then on the right side we have here another plug that is for a contact thermometer, so a contact thermometer. And this is if you want to have your temperature reference to be the liquid, because if you set a temperature here normally without the thermometer, then it will just heat the hot plate to this temperature. But if you plug in the thermometer on the back, then it will heat the media, so the liquid, to this temperature, not the hot plate. The hot plate will be hotter than the liquid, logically. And so you can plug it in here. Then here you have a hole that is made for the thermometer, so you are supposed to put a steel bar here, and then you can just clamp the thermometer onto the steel bar so that it doesn't fall into the liquid. Yeah, so that's all for just a general overview. I'll just plug it in and show you how it works. So let's just plug it in, do a quick focus, yes, then put a flask with a stir bar on it, and then you can just start stirring. So turn it on and set your speed, and as you can see, it starts stirring. So the advantage of this system, as said, is that it's contactless. So it also stirs when I lift the flask up, and then you can vary the speed. It goes very fast, and you can also go up to 0. So that's the stirring part, allows for stirring media and chemicals, very practical. And then on the left side we have the heating part, so you can turn it on by flipping this switch to on, and then I can set the temperature, and as you can see, as soon as I set the temperature, it turns on. This LED shows that the relay is flipping and that the heating is on. So you know when it's heating up. Yeah, so that's how it works. There are no more function on it. Sadly, I don't have the external thermometer to show you, but yeah, we'll go like this. Let's see what's inside then. So just flip it over. As you can see, there are 4 screws here. They need to unscrew to show you the inside of the machine. As you can see, the machine is not waterproof, so that's a little bit of a problem. So if you spill something on it, it will just go through the grill here and just spin onto your workbench. So it's not waterproof. That's something that modern Magnetstirrer have, but old ones do not. So we'll take the cover off. Oh, there's still a screw in there. Or this one. Yes. I'll just put 2 screws back because else the motor will fall out, because it's holding the motor in place. Let's just quickly screw them in. Yes. So, can I put it upright? Yeah, more or less. Let's do one more time a quick focus. Yeah. So, as you can see, there's the motor here in the middle, and it's the stator that is turning. And as you can see, on the side, there's the ring that is perforated, so there are holes in it. And this ring is going between an infrared LED and an infrared sensor. So this is sensing the speed of the motor, because the speed control is active. So it's always looking that the speed that you want with the knob is actually the speed at which it's spinning. So very precise equipment. So all the left side here is the stirring part with the speed control, and the right side is the heating part with the hot plate. So there's a transformator, and here the relay that we have seen, and then there are some circuits and resistors, condensators for the hot plate. And the way the speed control is working is that it's sensing first the frequency at which it's spinning here. So you have more or less a sinusoidal signal that is coming out of the infrared sensor, and this one is then squared, and then it's compared to what you want, to a frequency that you are generating with the second knob. So there's a circuit that generates a frequency, so a square frequency with the knob, and then it's compared between the two, subtracted, and so the difference is just like impulses that are then used to drive the motor. So then these pulses go to a triac, and then it activates the motor. So it just works by logic. If the motor is spinning faster than what I want, then it stops powering the motor, and when it spins slower than what I want, then it powers the motor, and so it spins and it gets faster. So it's active speed control. And on the side of the thermometer, it's a thermostat, so it's always comparing the temperature. When it reaches the set temperature, then it stops heating. So all the two are active control, and this is because it's lab technology and it needs to be precise. And for repairing this device, I needed the schematics, and I asked the company Ikamag, and they were really professional and kind and sent me the service manual, to my surprise, because today no one wants you to send you the service manual, and they did. So a big thanks goes out to them, because it was really professional from them, and they also gave me some advice how to repair it. So that's a great company, and they seem to put some value on having serviceable devices that last in time, and not just something cheap that will get busted in a few years. So, as you can see, the service manual is, yeah, pretty well made, I must say. Here you have all the components from the steering part, because this is the Drehzahlregler, so the steering part of the stirrer. And there are all the components listed here with the references. So if you need to change one component, you just look it up here, and then you can buy a new one. Then, if you look onto the second page, you have all the schematics and how it works. So this is only the steering part. Interesting enough, this service manual is from the 8th February 1984, so it was made 1 year before the stirrer. And yeah, so that's how it looks. Here you have the LED and the sensor, and this is what it makes, a sinusoidal frequency, and then it goes here through a comparator, and it becomes squared. Then it's comparated here to the knob, and then here you have the triac that is powering the motor here. So yeah, I won't explain everything, but it's basically how it works. And if you want to know which component failed on my device, it was this resistor here. I never thought that a resistor could fail, and I just replaced it, and then it worked again. Because the problem is that this resistor was in the power supply, and yeah, it was broken, and so the whole circuit wasn't powered, and so the steering part didn't work. So yeah, that's all for this episode. I just do a focus on this schematic. If you want, you can screen so that you have a schematic of this Magnetstirrer if you want to repair your device. That's, I think, all for this video about this German quality Magnetstirrer. It's old but still good. If you like the video, just put a thumbs up. You can write everything you want in the comment. Subscribe to the channel if you want to see more old but good technology, and I will see you next time.